Hello everyone, I am Professor Nayanasne, Department of Information Technology, Parvati by Genba Mose College of Engineering, Pagoli, Pune. So we'll start with the half portion of your Unit 5, that is your gang of 4. So why the gang of 4 name is given? Because the 4 authors named as Enrich, Richard, Ralpham and John publish a book with the title or book having the title Design Patterns Elements of Reusable Object-Oriented Software, which initiated the concept of design patterns in a software development. So they have introduced a numbers of patterns which will be using for a reusable solution for commonly occurring problems. So that for that study of that patterns, they have 4 peoples which are involved for introducing these patterns to the world. So it is called as the gang of 4. GOF, that is a gang of 4, name of 4 authors which introduce a title or introduce a book for design elements with different patterns and sub patterns in it. So we'll study one by one. So these authors are collectively known as gang of 4. According to this author, the design patterns are primarily based upon the principles of object-oriented design. So the first thing they are telling us the program to an interface, not an implementation. So that is the program to the interface but not for the implementation. And second one is the favor object composition over the inheritance. So instead of using inheritance, they go for the object composition. So let's see. A design pattern provides a general reusable solution for the common occurring problem in your software design. So the patterns typically show us the relationship and the interaction or the communication between your classes or your objects. The idea is to speed up your development process by providing well-tested, well-proven design and development patterns, or we can say the solutions which are readily available. So the design patterns are programming language independent. So they do not rely on a particular programming language. So they are totally a programming independent language for solving your common problems that are occurring in your design phase. That means a design pattern represents an idea but not an implementation, so that you cannot directly implement your design patterns, or we can say the design template, into directly the code or directly into the implementation with the proper coding. They are just an idea how to solve a particular problem, how to solve a common occurring problem. By using a design pattern, you can make your code more flexible, more reusable and more maintainable. So moving next, it is not mandatory to implement your design pattern in your project. Design patterns are not actually meant for the implementation or not made for the project development. They are made for common problem solving which occurs commonly in your design phase. So they are meant for common problem solving. So whenever there is a need, you have to implement a suitable pattern to avoid such problems in the future. To fit out which pattern to be used, you just have to try to understand the design patterns and its purpose. So only by then you will be able to pick the right pattern. So there are different types of patterns which they have introduced, but for a particular problem you have to choose a particular problem, or we can say a particular pattern. So it depends on a study of the design pattern and its purpose, which pattern should be used in which situation, or we can say for which will be suited for which problem. We have to choose such a pattern which will be suited or which will be totally reflect the solution for a particular problem. So that is depend on the study of the pattern. So suppose we'll take an example. In many real world situations, we want to create a single instance of a class, such as if you take the example of your president of a country. So there is only one president of one country at the time, regardless of the personal identity. This pattern is called as singleton pattern, where only a single instance of class is created. So that pattern is called as a singleton pattern. Whenever there are problems which are instantiated for a class which are having a single object, so that time you can use the singleton pattern. Singleton, as the name suggests, a single object is created for that particular class. you cannot create multiple object or multiple instance for that particular class. So if you are using a singleton pattern to refer any class, that class should create only a single object, or it should be instantiated at the single time. Suppose there is a database class, so you cannot make a multiple connection or multiple instantiation of that database class. You should create only a simple one instance which will refer all the connections. Okay, so that is your singleton pattern. As such, example of your president. So one country is having one president, all the problems, all the things are related with the, or which are linked to the presidents. All the we can say all the decisions which are make in throughout the country, the big decisions, the small decisions, they are undergone with the president's decision or the president phase. So one country, one president, that means one class, one object, that is known as a singleton. So suppose we have to remember a singleton pattern, remember one country, one president. So that is the example of the singleton. We'll see now the types of design patterns. The first is the creational, second is the structural, and third is the behavioral. So we first will see the creational pattern. So these patterns are all about the class instantiation and the object creation. This pattern can be further categorized into the class creational objects and the object creational patterns. Okay, so these are mainly related with the class instantiation and the object creation. This can be also further classified into the class creational patterns and the object creational patterns. So these are again two subtypes of the creational patterns. While the class creational pattern use the inheritance effectively in the instantiation process, and the object creational pattern use the delegation effectively to get its job done. So we have certain examples of these creational patterns. So the creational design patterns are further classified into the factory method. This is again one pattern. Abstract factory, that is another pattern. Builder is another pattern. Singleton, as we have seen previously, one class, one object. Next one is the object pool, and last one is a prototype. So this abstract factory method, builder, singleton, object pool, and prototype, these are the different types of pattern, sub patterns under the creational pattern. And creational pattern is totally related with your object creation and the class instantiation. Okay, so we'll see these sub patterns later on. Suppose there is again we have example given of the same. This is example of the singleton pattern, as we have seen previously, that the database connection should be not given multiple times if you are using a singleton pattern. Okay, only one class should be initiated, one object of that DB connection should be initiated to all the operations of your, to perform all the operations of your database. Second is your structural pattern. So these design patterns are all about to organize your class, to organize your objects from a large structure to provide a new functionality. So when the structural pattern is used, when the organization of the classes and its object for a complex and the large structure is needed, then we'll use the structural pattern or templates for the structural pattern. The structural design patterns are like adapter, bridge, composite, decorator, facade, flyweight, private class data, and proxy. So these are the different sub patterns under the structural design pattern. Depend on the problem, we need to choose the proper pattern from the structural pattern. Suppose there is an example that two different interfaces are not compatible to each other, but still we want to make a connection between them. We need to relate them, the both interfaces, or we need to communicate the two interfaces. So the adapter design pattern is the one pattern which will convert one interface into the class, so that the two different interfaces can be communicate with each other, or they can be establish a connection, or they can be relate to each other to function properly. So the clients expect that the adapter lets classes work together that could not otherwise of the incompetency. Okay, so two interfaces are not compatible to each other, and we have to make the relation between two interfaces. So the adapter is design pattern is the one thing which we can use to convert the interface of a class into the another interface or a class. So interface can be converted into the another interface or with the class, so that we can communicate that two different interfaces which was not compatible, but using adapter design pattern we can communicate them by converting one interface into the another interface, or by converting that particular interface into the classes. So in this situation, the adapter design pattern interface, or we can say the pattern, is used. The next is behavioral. So behavioral patterns are all about identifying the common communication pattern between the object and realize this pattern. So the behavioral pattern are the chain of responsibility, command, interpreter, iterator, mediator, memento, null object, observer, state strategy, template method, and the visitor. So these are the sub patterns under the behavioral pattern. So we have seen each and every pattern with the sub pattern. Suppose there is a template class defined as a skeleton of an algorithm. I'll just simply explain you the behavioral pattern. Suppose there is an algorithm. We have to change the algorithm without modifying its functionality. So the template method lets subclass redefine certain steps of an algorithm without changing the algorithm structure. So what we have to do, we have to change certain steps. We have to just check. Suppose there is an example of performance. So if you have to increase the performance, you don't modify the functionality of the core functionality of that particular class, you just modify the non-functional requirement. Same as in behavioral pattern, if we are going with the behavioral pattern, so if we need to change only and only the algorithm steps which are not directly impacting our algorithm structure. So here you can see the line, the template method lets subclasses redefine certain steps of an algorithm without changing algorithm structure. So we are not changing the algorithm structure, we are just changing some steps of algorithm. Suppose an example in your project that you want to behavior your module that can be extended such that we can make the module behavior in a new and different way as per the requirement of an application change. But we are not modifying any functional requirement. Okay, we are just changing some steps of that particular functionality. So no one is allowed to make change in a source code. That means you can add but can't modify the structure. You can add the things, you can add the steps, but you cannot modify the previous steps. So in this scenario, the template we have seen here, the template method design pattern is used in such a application where you need to add something, or you need to add certain steps to the algorithm but not changing the algorithm structure. So in such a situation you can use the template pattern which is under the behavioral pattern. So likewise there are certain patterns with different patterns, which are the three mainly. First is the creational, structural, and behavior. So we have in that sub patterns also. So we'll study one by one that sub patterns which are included in your syllabus. So might be there is observer, there is singleton, there is factory, abstract factory, which is included in your syllabus. So that we'll see in the next session. So if you have any doubt, you can comment in comment section, or you can ask me in a Zoom session. Thank you.